So I chose question number 5 to do for my problem. And it says a company produces two types of solar panels, A and B, that sell for $6 million and $4 million per 1,000 units, respectively. The cost in millions of dollars of producing X thousand of type A and Y thousand of type B is X squared minus 4XY plus 9Y squared plus 14X minus 42Y minus 2. Find the values of X and Y that maximize the company's profits. All right, so we know that to find profit, we have to take the revenue minus the cost. And our problem already gives us the cost function. So C x y equals x squared minus 4xy plus 9y squared plus 14x minus 42y minus 2. All right, so how do we find the revenue function is the question. And it actually gives us part of it in the equation. It gives us 6 million and 4 million, right? So we just have to add a couple variables to that to make it relevant to revenue. So we're going to do rxy equals 6x plus 4y. All right, so those variables, we can input any number and we can get the amount per 1,000 units that we're going to put out. So, like I said earlier, profit is cost minus revenue. So we're going to go, or revenue minus cost. So we're going to go profit equals 6x plus 4y minus x squared minus 4xy plus 9y squared plus 14x minus 42y minus 2. All right, so we have our revenue function here and our cost function here. So when we put those together, we're going to come out with negative x squared plus 4xy minus 9y squared minus 8x plus 46y plus 2. All right, so here's our total profit function. But we can break it down a little further than that. We're going to take we're looking for the maximum, right? We're looking for the maximum, the values of x and y that will maximize the company's profits. So we're going to take the partial derivative of our revenue function, of our profit function here. First, we're going to take the partial derivative of x, which we're going to break down into, so we'll go d x equals, which is going to end up being, we're going to take the derivative of negative x squared, which is going to become negative 2x. Then we're going to take the derivative pertaining to x of 4xy, which is going to just be 4y, so we're going to have plus 4y. And then we're going to, the only other number in this equation that has an x is our 8. So it's going to be the derivative of negative 8x is simply 8. So now we need to take the derivative of y as well, pertaining to y, that is. So we're going to go equals, so we're going to take the derivative of 4xy first, and our x's or our y is going to disappear, so we're going to have 4x. Then we're going to have the derivative of 9y squared, which is going to be minus 18y. And then, of course, 46, the derivative of that is plus 46. Okay, so now what do we do from here? We have our so now we can solve for y on both equations, and they're going to equal each other. So let's do that. So let's bring the 4 to the other side of the equation. It's going to be negative 4y equals negative 2x minus 8. We're going to divide by 4 there, and we're just going to have y equals negative 2x minus 8 over negative 4, which is going to it's going to break down into basically x minus 4 over 2. So we have y equals x minus 4 over 2. Then we're going to go over here and we're going to bring 18 to the other side, 18y. We're going to have 18y equals 4x plus 46. Then we're going to go down, y equals 4x plus 46 over 18. When we divide that 18 over, and that can be rounded down to 2x plus 23 over 9. So now we're going to use our substitution technique. It's kind of a cool little trick. First we're going to have x minus 4 over 2 equals 2x plus 23 over, x plus 4, sorry. 2x plus 23 over 9. Alright, so what we're going to do here is we're just going to cross multiply. We're going to put the 2 up here and the 9 up here, so it's 9x plus 4 equals 2x plus 23. After we FOIL that, it's going to end up being 9x plus 36 equals 4x plus 46. Okay, so finally, that was kind of a long process. I apologize for that. After we break this down a little bit, we're going to minus the 4 to the 9 side. We're going to get 5x, combine like terms here, and then we're going to have 10 over here. If you divide that over, x equals 2. Okay, so we have x equals 2. That's one of our answers. What do we do with that? We're going to plug that back into an equation. I'm going to go on to a new piece of paper here, but I'm going to leave that there for reference. So we're going to just plug this back into what y equals so we can find the answer. So we're going to have y equals, in place of x, we're going to have 2 minus 4 over 2. And that's going to be 2 plus 4. Sorry, I keep making that mistake. I'm just going to change that up here so I don't make that anymore. But we're going to have 2 plus 4 is 6, divided by 2 is 3, right? So y equals 3. So we have x equals 2, y equals 3. We have everything, right? Not really. We have to find out if this is going to be a maximum or a minimum. So how do we do that is we're going to do a little bit, it's called the second derivative process. We got to go through this process real quick. So we have our first derivative of x up here, our 2x plus 4y minus 8. Then we have our first derivative of y as well. So our second derivative of x, it's just going to be squared equals, that's just going to be negative 2. Our second derivative of y, if we look at this, we're just going to look for our y's. Our only y is on the negative 18. our second derivative y ends up being negative 18. We also have to add one more thing to this, which is our derivative of x and y. So that's just the whole derivative. And that second derivative is going to be just going to be 4. All right. So we have these three things. Now we got to put them into the equation for the second derivative test, which will be our second derivative of x. So we're going to have negative 2 times our second derivative of y, which is negative 18, and minus our whole derivative of x and y, so minus 4. So we're going to get 36 minus 4 equals 32. All right, so our second derivative test has a few rules. If our result of this equation right here, the second derivative of x times the second derivative of y minus the whole derivative, the whole second derivative, if it's positive, so if dAB is positive, if it's greater than 0, I should say, and our first derivative of x, or our second derivative of x, is less than 0, so x is less than 0, then our derivative is a maximum, and it's the opposite for minimum. So if we check that, is our first derivative of, is our second derivative of x less than 0? Yes. Is our formula here greater than 0? Yes. We have our maximum. Our answer is going to be 2,000 units of solar panel A and 3,000 units of solar panel B. Here's our answer. Thanks for watching.